Good afternoon everyone, my name is Mohamed Bilal and today I'll be presenting to you my final year project presentation. So, my final year project will be focusing on the design and the development of the optimum bioreactor. So, before I go into detail about my project, I will be giving you a background of my project, which is about tissue engineering. Okay, so let's start with a story about tissue engineering. So this photo here shows a picture of a part of a lung called trachea. So this trachea was grown inside a laboratory by a group of scientists in 2012 in Sweden. Later, this trachea was used as an organ transplant for a patient who was suffering from lung cancer. And this later went on to even save his life. So I hope you are able to relate to my project, because I'm sure some of you may have loved ones who are suffering from terminal illnesses such as cancer. And tissue engineering can be the solution for your problems. So tissue engineering can be divided into two broad fields. It can be divided into in vivo tissue engineering, which refers to growing the cell culture inside the biological context. In this case, a laboratory mice. In some cases, the biological context can even be your own body. In vitro engineering, on the other hand, refers to growing the cell culture outside the biological context of the microorganism. In this case, it can be glass containers, test tubes, or bioreactors. So bioreactors are extremely crucial in tissue engineering. They are used to simulate the physiological environment for cell culture, and they are needed to promote the growth of cell cultures. My project will be focusing on bioreactors, and to be more specific, I will be focusing on perfusion bioreactor, which is the most sophisticated bioreactor in the industry. However, perfusion bioreactors are still not up to date. Firstly, we don't know what the best type of cells that can be used for the growth of, for the maximum growth. Moreover, we still don't know what are the best dimensions of bioreactors so that we can grow these cells at a faster pace. And lastly, we don't know what are the flow patterns of the medium to be used so that we can maximize the output, the cell seeding efficiency of the cells. So the objective of my presentation, or the objective of my project, will be to design the optimum bioreactor that is able to efficiently promote the growth of cell culture in the scaffold. So when I say scaffold, I refer to the bed in which the cell cultures can actually grow and flourish. So this shows the outline of my project. Firstly, we will be designing the dimensions of the perfusion bioreactor. After that, we will set up the scaffold in which the cells can be deposited into. And lastly, we will conduct a series of experiments to determine the maximum cell seeding efficiency. And from the results of these experiments, we can decide what is the best bioreactor that we can use to maximize the growth of such artificial organs. So let me end with this quote by Robert Lazar, who's a famous medical doctor and scientist in America. He said, with tissue engineering, you can actually grow up artificial organs, such that in the future, if you get into an accident and you lose your kidney also, you can actually grow up a new kidney in a test tube using tissue engineering. Yes, you have few skin cells from your own body. With that, I would end my presentation, and thank you for listening.